Here is a list of some of the example SUMIFS formulas we will be creating in this in-depth tutorial. Stick around to the end to see how you can even automatically add column and row headings to your resulting matrix. Welcome to this comprehensive tutorial on Excel's SUMIFS function. Whether you're analyzing sales data, financial reports, or any data with multiple categories, SUMIFS is your powerful ally for complex calculations. Let's break down this function step by step, from basic usage to advanced techniques. Before we start creating SUMIFS functions, I will assign names to our cell ranges. Using range names for function arguments makes them easier to read and understand. Let's first start with a simple SUMIFS function that uses a single condition. We want to find the total sales for Fort Wayne. I will start the formula with the equal sign and then the function name followed by a left parenthesis. The first argument in the function is the sum range. The sum range is the cell range that contains the values we will add for any sale in Fort Wayne. The cell range is C2 to C11, which I named Sales. I will enter the comma to go to the next argument. The second argument is the criteria range, which is the cell range that we will search for Fort Wayne. The cell range is A211, which I named Cities. The third argument is the criteria, which is the item we are searching for, Fort Wayne. This formula sums all values in column C, where the city in column A is Fort Wayne. It's like asking Excel, what are the total sales in Fort Wayne? I will press Enter. The result is 2,000. What if we wanted to know the total sales for each city? Before we create the function to do that, let's create a list containing the name of each city. We can do that by using the unique function. I will enter the unique function in cell J2. I will use cities for the argument. Now I can enter the SUMIFS function starting in cell K2. I will use sales for the sum range. I will enter a comma and then select cities for the criteria range. I will enter a comma and then enter cell address J2 for the criteria. I will press Ctrl plus Enter. To copy the formula down, I will double-click on the autofill handle. The result is the total sales for each individual city. Let's create a SUMIFS function with a second condition. The function will sum values where the city is Fort Wayne and the product is printer. We will use sales for the sum range and cities for the first criteria range. We will use Fort Wayne for the first criteria. Next, we will enter product for the second criteria range and printer for the second criteria. This shows how SUMIFS can filter data using multiple conditions. We will be creating multiple line function statements that we will enter in the formula bar. You may want to increase the font size for the text entered in the formula bar. To do that, click on File on the ribbon, and then select Options in the left pane. In the Options dialog box, change the font size to something like 18. This is a good size, at least for me it is. When you save the workbook, that size will be saved with it. You may want to change the size back to its original size before creating a new workbook, because when you create a new workbook, it will take on that font size. Sometimes you need to sum the results of multiple SUMIFS statements. In this SUMIFS function, we want to find the combined sales for Bloomington and Princeton. When summing the results of separate SUMIFS functions, we place the SUMIFS functions within a sum function. This function requires several lines, so instead of entering the function in the cell, I will enter it in the formula bar. Entering the function on multiple lines makes it much easier to read and understand. I will drag the formula bar down to provide more room. I will start by entering the sum function and the left parenthesis. I will create line breaks by pressing Alt plus Enter. I will enter the first SUMIFS function. The range that we are summing is sales. Because we have named our ranges, we can type the first letters of the range name and then select it from the list that appears. The criteria range is cities, and the criteria is Bloomington. Be sure to separate the SUMIFS with a comma. The second SUMIFS function uses the same sum range and criteria range. The criteria is Princeton. I will enter the closing parenthesis for the sum function. This gives you the combined total for the two different cities. Let's look at a SUMIFS function that uses multiple criteria to combine product categories. We want to combine the sales for those records where the product is a laptop and the quarter is 1, and those records where the product is a desktop and the quarter is 1. We have entered the arguments for the first criteria. Now, let's enter the arguments for the second criteria. I will enter quarter for the second criteria range and Q1 for the second criteria. The arguments are the same for the second SUMIFS function, except the product criteria is desktop. A more efficient way to handle multiple criteria conditions is using array literals. Let's look at functions using arrays that will get us the same results as the two previous examples, while only using a single SUMIFS function inside of a sum function. Let's first create the SUMIFS function, and then we will place it within a sum function. Array criteria are separated by commas and placed within curly braces. Running this function gives us the total sales for Bloomington and the total sales for Princeton. When creating functions that use arrays, the function is placed in the top left corner of the array. When you click on the other cells in the array, you also see the function, but it will be grayed out. I will copy the function. I will place the copied function within a sum function. The result is the combined sales for the two cities. This achieves the same result as the previous example where we added sales for Bloomington and Princeton, but more elegantly. For this example, I want to find the total sales for laptops and the total sales for desktops in quarter one. We can place the product criteria in an array. Quarter will be the second criteria range, and Q1 is the second criteria. SUMIFS supports wildcards for flexible text matching. We want to sum cities where the city name ends with TON or the name starts with green. The first condition that starts with asterisk TON will sum the products from Bloomington and Princeton. The second condition will sum the products from Greenwood and Greensburg. Let's look at how multiple arrays within the same SUMIFS function are treated. We have two criteria ranges, cities and products. Within the cities criteria, we have array constants of Fort Wayne and Greenwood. Within the product criteria, we have array constants of laptop and desktop. The result is two zeros. This is because the first item in each array is connected by an AND condition, and the second item in each array is connected through an AND condition. When we look at our data, no laptops were sold in Fort Wayne and no desktops were sold in Greenwood. I will reverse the items in the second array. Now the function will sum desktops sold in Fort Wayne and laptops sold in Greenwood. This function will return the sales for records where the city is Greenwood, the product is laptop, and the quarter is Q1. It will also return the sales for records where the city is Fort Wayne, the product is desktop, and the quarter is Q1. This function will return the sales for records where the city is Fort Wayne, the product is desktop, and the rep is Sarah. It will also return the sales for records where the city is Greenwood, the product is laptop, and the rep is John. I want to assign range names to all of the columns on this worksheet. Rather than naming them individually, I will select the entire data range, then click on the Formulas tab. In the Defined Names group, I will click on Create from Selection. I want the range names to be the same as the column headings, so I only want the top row selected. I will click on the OK button. You can also filter by numerical values. For this example, we will calculate the total sales from the East and West regions where sales are greater than 1,000. Before performing a SUMIFS function, we would like to know if the criteria we are testing for matches any of the records in our data. If no matching data is found, we want the message "no matching data" to appear rather than a 0. The regions East and West both have sales, so the function displays the results of the total sales for each of those regions. I will add a Y to the end of East and press Enter to run the function again. There are no sales for Eastie region, so the function returns no matching data. I will change West to Westie and then press Enter to run the function again. There are no sales for Westie region, so the function returns no matching data. Let's explore a formula that calculates the total sales for specific regions within a defined date range. This is an essential tool for anyone tracking regional performance over time. The regions East and West will be summed separately. The date functions ensure that the records being summed must have a January date. The ampersand in front of the date function is used to combine the comparison operator with the date value returned by the date function. Excel requires the entire comparison condition to be expressed as a single string. Together, these conditions give us the total sales for the specified regions during January 2024. If you're a sales manager, this formula can help you quickly analyze sales trends and decide where to focus your team's efforts. In this example, we will be using round, SUMIFS, and COUNTIFS together to calculate the average sales for the East and West regions, then rounding the result to 2 decimal places. This formula is structured as follows. The SUMIFS portion of the function adds up values in the sales column, where the region column matches either East or West. The COUNTIFS portion of the function counts the number of sales records specifically for the East and West regions. This function is helpful because we want to get the number of entries that meet our criteria so we can calculate an accurate average. Finally, we use round to format the result. By passing 2 as the second argument, we're rounding the average to 2 decimal places. This formula calculates the percentage of returns for specific sales channels and product categories. If you're in e-commerce or retail, this is a must-have skill. This combination of SUMIFS functions shows the returns percentage for laptops and desktops across online and retail channels. The numerator sums up the returns for online sales of laptops and retail sales of desktops. The denominator sums up the sales for online sales of laptops and retail sales of desktops. Dividing the total returns by the total sales gives the return rate. Multiplying by 100 converts it into a percentage. Imagine you're managing a sales team and you need to determine the net sales for two top reps, John and Sarah, for January. This is critical for tracking their performance after accounting for product returns. The first SUMIFS function adds up all the sales that meet the specified criteria. The second adds up the sales returns for the same criteria. Returns are subtracted from sales to give us net sales. This array statement returns two results, one for the net sales of online products sold by John, and the other for the net sales of retail products sold by Sarah. In this example, we'll explore how to calculate the percentage of total sales that come from the online channel compared to both online and retail channels. The first line calculates the total sales from the online channel. The second line sums up sales from both the online and retail channels using an array constant for online and retail. Dividing the online sales by the total sales and multiplying by 100 gives the percentage contribution of online sales. I will change the result type to number so that it will display only two decimal positions. This formula calculates the percentage of total sales that happened in the first quarter. This is perfect for understanding quarterly sales trends. It's ideal for tracking sales performance across different time periods, whether quarterly, monthly, or even annually. Now, let's break it down. This sums up all the sales data from quarter one. This sums up all the sales data from the entire data set. Divide the quarter one sales by the total sales and multiply by 100 to express the result as a percentage. This gives us the share of quarter one sales as a percentage of the total sales. This example shows you how to calculate the percentage of a product's total sales, like laptops, that comes from online sales versus retail sales. This formula is essential for understanding the performance of your sales channels. Here's how the formula works. This line sums up the sales revenue of laptops sold online. This line sums up the sales revenue of laptops sold in retail stores. Adding the two values gives the total laptop sales across both channels. Dividing the online sales by the total sales and multiplying by 100 gives the percentage contribution of online sales. The formula calculates what percentage of laptop sales come through the online channel. This example tackles a powerful formula that calculates the percentage contribution of a specific product, like laptops, to total sales in a particular region. This formula is perfect for understanding product performance at a regional level. The formula returns the percentage of East region sales that come from laptops. Here's how the formula works. This line sums up the sales revenue for laptops in the East region. This line calculates the total sales revenue for all products in the East region. Divide the two values and multiply by 100 to express the result as a percentage. Let's dive into a formula that every business analyst and manager needs to know. We'll calculate the percentage of online sales that are highly profitable. This formula calculates the percentage of online sales where the profit exceeds $300. It's incredibly useful for tracking high-performing sales and understanding where your business is excelling. This formula is a fantastic tool for gaining actionable insights into your sales data. This formula has two main parts. This line sums up the sales revenue for online transactions where profit is greater than $300. This line calculates the total sales revenue for all online transactions. The formula divides these two values to find the proportion of high-profit sales, then multiplies by 100 to convert it into a percentage. The result is 68.83%. This means that 68.83% of online sales have profits greater than $300. This calculates the percentage growth or decline in sales for the East region from the prior year to the current year. Whether you're an analyst, manager, or entrepreneur, this calculation is crucial for tracking your company's success. Let's break down the formula. This line adds up all current year sales for the East region. This line adds up all prior year sales for the East region. The formula then finds the difference between current and prior year sales, divides that by prior year sales, and multiplies by 100 to get the percentage growth. There was a 17.39% increase in sales for the East region compared to last year. This formula dynamically lists all unique products and calculates their sales for the East and West regions, all in one go, as well as creating both the row and column headings. Let's break the formula down. The let function defines reusable variables within the formula, making it easier to write and read. This line extracts a unique list of products from the products column. This line calculates total sales for each product in both the East and West regions. H-stack and V-stack combine headers and data into a neatly stacked and aligned table.